All right, good morning. It is 9:30, so we'll go ahead and get started. Okay, so first we'll talk about the class material for this week, and then we will discuss the assignment, and I can kind of give you some example that you can go off of. All right, so this week was all about functions. So what is a function? A function is just a piece of Python code that somebody else wrote that you didn't write. Now, you can write your own functions, and we'll get to that towards the end of the discussion. But at least here at the beginning, what we will discuss is function is just Python code that already exists somewhere else that you can use instead of doing the work yourself. So what does it look like to what we say is call a function? When we say call a function, it means I want Python to do the work of this code and either give me an answer back, or you can have functions that don't give you an answer back, and we'll see examples of all of those. So we'll start off by talking about some of functions that are just built into Python. The one you've already seen of the most is print. It looks like this. Right? If we do that and we run it, of course, it does what we expect. Python file. Oops. There we go. It just prints something, right? This print is actually a Python built-in function, meaning it's a function that Python automatically provides to us that does some work for us. And what the print function does, it takes whatever input you give it, and it just prints it to your screen. That's what this print function does. So the name of the function is print. And then we have these open and closed braces, parentheses. And then inside of here, we have what we call the parameters. It can also be called arguments. Arguments and parameters are kind of interchangeable. And you'll see sometimes I use arguments, sometimes I use parameters. But these are the parameters that you're giving the print function. And those will be unique to each type of function. For print, it expects you to give it the string that you want to print out, right? So for this print function, there is one parameter, and that parameter is the string that you want to print. And you can see right here, whenever we use that built-in function, it does indeed just print it to the string. So that's one Python built-in function. Another that you've been using a lot is input. Actually, let me put the print one back up there. Right? So, just explain the print. Input is another Python built-in function. It also takes one parameter, and that parameter is the prompt that you want it to be. Actually makes more sense if we put this as the prompt. Oops, there we go. And we'll print S again. So input is another Python built-in function. The parameter is the prompt that you want printed on the screen. But there's a little bit of a difference between the input and the print. For input, we have this S equals to, and S is just a variable. It can be whatever we want to call it. I'm just putting S for string, right? But when we say S equals a function, that means the function also returns something to us. Meaning the function takes this as input, this is the parameter, and it returns something to us. It gives us some kind of value back. And throughout your previous assignments that input will give you whatever the user typed in at the keyboard, right? That's what is stored in S. So S is equal to whatever the function returns. So there's kind of three concepts. We have the function name, the function input, which is its parameters, and the function output, which is what it returns back to us. Now, where is the code for this input? The code that actually does that work, it is somewhere else. For these, it's specifically built into Python itself, but there is actual code that does this input somewhere else that we didn't have to do. I mean, if you think about when we do the input, what has to happen in the background? Well, it has to find the terminal. It has to print out individual characters on the terminal. It has to wait for you to type something in at the keyboard. Then it has to give that back to you, whatever they typed in at the keyboard. So there's 3 or 4 different steps there that have to take place, but you don't have to do any of that because this function is doing that work for you. But it is still code that somebody else wrote at one point. So if we run this, of course, it does what we expect. It does print something with that function. Now here we're at this input function. This was the parameter, and as you can see, that's what it prints out as a prompt. And now it's just sitting here waiting. And that's because the input function, it will return to us whatever's typed in. So let's just type in whatever. And now we're going to call the print function again and give it that string that the user typed in, and it prints it out. There's a couple other, well, actually, there are a lot of Python built-in functions, but we're just going to talk about 2 more of them right now. So we have that. You know, we've been doing this already in your assignments. Enter an int, call it I. We'll say f equals input. Enter a float. Remember when we were having these things? This is actually a function inside of a function. So let's look at just those 2. So we have a function called int, right? We have a function called int. Inside of there is what we want to convert into an integer. Normally it's a string, right? So if we have, normally we've seen things like this, int 5, right? If we print I, that should give us 5, right? Because the integer expects a string as a parameter. Likewise, this integer expects 1 string as a parameter, but we can combine them like this because what does input return? Input returns a string, right? So when we have this code right here, ignore the int for a second. When we have this input function, this is really turns out to be a string because input returns a string to us. And since input returns a string, we can use that string as the parameter to the int method. You know, that's these 2 things are the same. One's just a shortcut for each other. Put all this stuff further away. This right here is the exact same as this right here. Input returns a string, which we store in S, and then we turn that string into an integer. Input returns a string, and we use that string as the parameter to that int method. And the int method returns to us an integer number. That's why we have the I equals there. Likewise, float method takes this string as a parameter and it returns to us a float number. So if we do all this, let's print out the type of I, and then we'll print out what I is, and then the same thing for F. We run that. See, enter an integer 45, enter a float 3.14. There we go. The 45 was an int, and that's the actual number. And the same thing with the float here. Okay. Oh, we actually used another one here. This type is a built-in Python method. It takes a variable as its parameter. So this I is this variable. It takes the I as a parameter, and the type also returns a string. So the type returns a string, and so we then call this method, call this function print with this string. Okay, so really kind of key thing to know here then is a function looks like this: function name, function parameter, function return value. It kind of looks like that, where you had the function return value. In this case, we have F. It's equal to the function name. In this case, it's float. And then we inside of it, we had the function parameter, which this was the parameter. Okay. Now, you don't need to have, I'll get to your question in a second. You can have more than one parameter, meaning you can have a function that has multiple parameters, and we'll see one here in a minute. But these functions just needed one parameter, so that's all there is. So the question is, so once you've made I an input variable, the previous I equals 5 becomes void. Yeah, that's correct. So here I said I is equal to this integer 5. This is just changing the value of I. So that 5, it kind of went away and no longer exists. We're just saying we have a variable I and it's the number 5. Now we're saying the variable I is equal to the number of whatever you type in. So you've kind of lost the 5 at that point. All right, let's look at some other functions that have more than one parameter. Well, let's look at two more. Yeah, look at a few more built-in methods that have more than one parameter. Okay, we have one called min. So let's just say A is equal to the min of 3 and 4. So this min is a built-in function, and it will return back to you the smaller of the two numbers. So if we have 3 and 4, then what would A be? A would be equal to 3, right? Print A. You run it. Sure enough, we get the answer as 3. And that's because this min function, it takes 2 parameters. And you can see they're separated by this comma. So it takes 2 parameters, and it will return back the smaller of the numbers. So if we have 30 and 4, of course, it's going to return me 4. And it does right there. You know, opposite of that, we have max. Max will give you the bigger of 2 numbers. We run that, we get the 30. And it doesn't have to be hard-coded values like that. Enter a number. B is another int input. It can be something the user types in. another number. We'll say we'll get the min of that first. Oops, min, and then we'll say the min is S. Right, so it can be something that the user types in. So if we run, oops, not 30 and 4 anymore, now it should be of A and B. So we're going to have the user type in a number and store it in A. We'll have the user input another number, store it in B. We'll do the min function that gets that'll tell me the smaller number. It returns it into S. And then I'm just going to print out the min is, whatever is that S variable. So if I type in 1 and 2, the min is 1. If I type in 1, 1, 1 and 3, 4, 5, the min is 1, 1, 1. Of course, we can just change that to max. And then I can say the max is 1, 1, 1, 3, 4, 5, 6, 7, whatever. That's the max. So that's another built-in Python function that takes two parameters and tells you which one is bigger. One more of the built-in ones, and it's called length. We'll say A is equal to the length. And for length, you give it a string. It wants a string as the parameter. And what this will give you, it'll tell you how many letters are in that string. So again, the function name is len, stands for length. It takes one parameter, which is a string. It returns how many characters are in that string. And then we're just going to print out how many characters are in the string. Do this. There are 6 characters in QWERTY. That's right. Put that in. There are 16 characters in that. We can do it on user inputs. Enter a string. Let's get the length of what the user types in. So this input we'll get from the keyboard what the user types in, and then the length we'll take that string and tell you how many characters are in it. Run it. This is a really long string, and there's 28 characters in that. All right. The next functions we want to talk about, they're not exactly built into Python, but they are code that another person wrote, and they store it in what we call a library. A library just means is another Python file that is full of useful functions. And the ones we're going to examine are a bunch of math functions, meaning stuff like square roots, powers, sine, cosine, logarithms, and stuff like that, right? Somebody else wrote the code for those, and we want to use their code instead of writing it ourselves. Okay. So they're not exactly built into Python. They're in what we call another library. So to use functions from another library, we have to use what we call import, and then you have to name the library. For math stuff, it's just called import math. What this means is there is a library called math, and we want to use it. We want to use those functions in our own code. Now, there are lots of libraries for a lot of different reasons. A lot of it is about documentation and doing some research about what you're trying to do and seeing if there's a library already that does that. We will focus on the math one. So how do we do it? So let's say we want to compute some number squared, right? Well, how does it look? We can say A is equal to 5 squared. That's how we can do the power kind of built in. But we can also do it like this: math.power of 5, 2. Those two are the same thing. This is 5 raised to the second power. This is using a function in this math library, and it has 2 parameters, and it returns to you an answer. So let's print A here. Let's print A here. You'll see they'll get the same thing, and then we'll talk about it some more. There you go. They both, well, one gives you 25.0 because it thinks it's a float, but you can make it an integer. So what is going on right here is POW, which stands for power. That's the function name. But you see we have math.pow. That means it's in the math library, and POW is the function inside that math library. And then if you want, you can look up the documentation and you can see that this POW function takes 2 parameters. One is, the number, and the second one is the exponent. Okay. And it returns to you, what 5 raised to the second power is. Now, looking at this one, you may say, well, we could just use this. What's the point of using the import math? Okay, well, let's say we want to get the square root of a number. There's a math function called sqrt. We can do math.sqrt. It takes 1 parameter. That's the number we want to get the square root of. It returns the answer, and then we print the answer. So now up here in just standard Python, how do we get the square root? Their answer is we really can't. There's not something, or not something we can type in here in just plain Python to get the square root. There's like some really complicated formulas to compute a square root. So do you want to write those complicated formulas yourself? The answer is no, you don't, because somebody already did it. Somebody already wrote the complicated formulas to compute a square root. And it's in this square root function inside the math library. So we don't really have an equivalent here to compute square root. So we use this math square root function. We run it. There you go. That is the square root of 111. Likewise, we have a lot of the math functions you may think of. We have sine, cosine, tangent. Have all those in the math library. There you go. That's the sine of 1. That's the cosine of 1. That's the tangent of 1. Some trigonometry methods or functions. We have log. You probably won't use a lot of these very much. That's the log base 2 of 100. And yeah, that's the main ones that come out of the math: the power, square root, sine, cosine, tangent, and log. There are a lot more in there, and you can go to your favorite search engine and look up the math library of Python and look at the documentation. It probably gives you 100 different math functions that are inside that math library. Those are just a few, but this is how we can use code that somebody else wrote, these functions that somebody else wrote, to do some kind of work for us. So that, like I said, when I went back to this square root here, probably if you wrote out the formulas yourself, maybe it's 100 lines long, maybe it's 500 lines long. I don't know off the top of my head how many lines long the formula is, or the algorithm is, to compute a square root. But you could either do that yourself, or you could rely on someone else that's already done it. So these functions are just other Python code that somebody else wrote, and you're wanting to use it. It just exists somewhere else. Where it exists, you don't need to worry about. Okay. So that's kind of the built-in functions. That's functions that are in other libraries, like I said, which is what the math one is. Now let's get to the good stuff. Let's talk about custom functions. Now these are functions that we ourselves write. And here's what they look like. So let's imagine I have this problem. Let's say I want to know if someone is a child, an adult, or a senior. You know, where does that sound familiar? Sounds familiar like our last assignment, right? So I need to figure out if someone is a child, an adult, or a senior. Okay. So first of all, let's start off by asking somebody how old they are. Say age is equal to, actually, let's start off with asking the year they were born. This will actually let us use two functions or write two of our own functions. So we'll have them enter in the year they were born. We'll take it one step at a time. So we're going to start off by just saying, have them input the year they were born, and then we're just going to print out the year. Run it. 1980. There you go. 1980 was the year they were born. All right. So now let's compute their age. Say age is 2021 minus the year. And we'll print out age. I know there's some wiggle room in there, depending on if your birthday's passed or not yet. We're going to ignore that wiggle room and just say the age is the current year minus the year you were born, right? Save it and run it. If I say 1980, then you're 41 years old, okay? So this right here, it's some kind of mathematical computation, right? And mathematical computations are really good candidates to have as a function. So let's make our own function that computes what your age is. And here's what it looks like. Your functions, your own custom functions, they should usually be placed at the very beginning of the file. And it looks like this. It starts off with DEF. DEF here stands for define. Then we put the name of the function. I'm going to call it compute age. Then we need to tell it what parameters do I need? What parameters does this function need to compute the age? Well, in order to compute the age, we need the current year and we need the year you were born, right? Just here where we computed the age, we needed the current year and the year you were born. So to compute the age, we need a current year and we need year born, right? So that's what this looks like so far. So DEF stands for define. That means I'm starting a function. Compute age is the name of the function. And then inside the parentheses are the parameters that this function needs in order to do its work. Then at the end, we have a semicolon. And then we start going down to the next line. And just like when we did with if statements in the previous week, spacing and tabs are very important in Python. So anything that belongs to this function, we need to tab over. So if this is tabbed over, this is a function line. This is a function line. You know, all these lines that are tabbed over are part of the function. This is not a function line. And that's because when it is no longer tabbed over, meaning once the tabbing ends, that means this is no longer part of the function because it's not tabbed over anymore. Okay, so let's actually do the work. Let's compute the age. So how do we compute the age? We say the age is equal to the current year minus the year you were born, right? Kind of the same thing that we had right here. We did the computation, but we're going to do it in a function now. Define function name, function parameters. Inside all this tabbed over stuff, we do the function work. And now we need to return what the answer is. We use it with return age, and then that'll be the end of our function. And so now we can call that function just like we would any other built-in function or any of those math functions. And how do we call it? First, we're going to say the age is equal to, we want to name the function. The function name is compute age. We need to give it two parameters, right? The function expects the current year and it expects the year that you were born. So we need to give it the current year and the year we were born, right? And we say age is equal to it. Why? Because we do the computation and then we return the age. Whatever we return is what gets set to that variable. Let's save it and let's run that. Say we're born in 1982. We're 39 years old. So now we did this age computation with our own function that we made ourselves. Now, here is where you can get into some trouble. So you see here, I have variables current year and year born, right? Whatever these parameters are, these are the only, let me take that a step back. You should not use, inside this function, you should not use any variable that exists outside of the function. And what do I mean by outside the function? Outside of the function is any variable that's not part of the function, right? So whenever I say this current year, well, for example, when I have this year equals to this, right? I should not use that year variable inside the function. And I don't, right? Nowhere in here do you see the year variable. I have an age variable here, right? This one's a little bit more tricky. I am using an age equals, but this age is different from this age because this one's outside the function and this one's inside the function. It's actually better if I name them completely different. We'll call this function age. It helps keep it more straight in your head. So the baseline rule is if a variable exists outside of the function, you should not use that same variable inside of your function. Now, if I did this, if I just put year here, let's show you where I can go wrong or show you what can happen. So here I'm going to say function age is equal to the year minus the year born. Year does exist. Year is right here, right? So this actually, it works. Well, year minus year born. Yeah, actually pseudo works, right? But the point is, these parameters are really about the only variables you should use. And if we look closely here, when we call compute age, we gave it these parameters. That means when it comes up to your function, this 2021 gets saved in the current year. This year, which is what the user typed in, it gets saved into that year born. So up here, let's do a print current year, and then we'll print the year born. So what we'll see happen, let's do it and then we'll explain what happened. Oops. You can see we printed 2021 and then we printed 1980. That's because this 2021 corresponded to this current year, and that's what we print out. This year, which is what the user typed in, corresponds to this year born, and that's what we printed out, the 1980. And that's because for the parameters, it was 2021 and then year in that order. So the current year is the first parameter. The year born is the second parameter. All right, so that computes the age. Let's make a second function that says whether you're old or not. So we can make another function called define old. Let's just call it old or young. So we will define a new function. The name of the function is old or young. Inside of here, we need to put the parameters. What parameter do you need to know to determine if someone is old or young? Well, we need their age, right? And you can call this whatever you want. We can call it AAAA. That's fine. It's just like any variable. You can name it whatever you want. And so, let's think about what computation we need to do to determine if someone's old or not. Let's just say if AAAA is less than, say, 50, then we're going to return young. Else, return old. I apologize if anybody is classified as young or old. I'm just making up these numbers off the top of my head. So what's happening here? So we'll print the age, and then we'll print old or young for that age. So what's happening here? So we already explained all this, the compute age and the age. Now we're going to call the function old or young. We're going to give it the age. This age is now this AAAA variable, and we're going to say if that's less than 50, we're going to return your young, the string young, else we're going to return the string old. And so since this function returns a string, we can just print that string. Let's save it. Let's run it. Born in 1980, says you're 41 and young. Let's say you're born in 1970. It says you're 51 and you're old. Right? And I use my two built-in functions here. One more time before I talk about the assignment. We define the function name. These are the function parameters. We do the computation. We return the answer. So when we call the function, we say of the variable is equal to that function name with the two parameters. So now it's going to do all of that work, return the answer to me, and then I just print out the answer. I got a question. Fine. Hold on a second. Spin that out. All right. So let me read this question. What's the purpose of the return command as opposed to the print function? Okay. No, that's a very good point. So generally, you don't want to, especially if it's a function to do some kind of computation, you don't want to do any kind of printout. And here's why. Well, he's asking about the difference between the return and the print. So what we could do here, let me think of a good example. Okay, yeah, actually. So let's think about like last week's assignment where you had to do movie tickets based on if they're a child, they're a senior, or they're a normal adult, right? So let's do something similar, except we're just going to do different prices if they're young or if they're old. Okay. So let's look at this. So we'll enter the year you were born, we'll compute the age, we'll compute old or young. Say OOY stands for old or young. So now we want to do something if you're old or young, right? If old or young equals young, then print say cost is equal to 0. Say cost plus equals $5 if you're young. Else old or young equals old. And the cost plus equals $3. And print the cost. Oops. Okay. So what's happening here? So all this stuff right here is the same. We're asking the year you're born, computing your age. We're computing if you're old or young. And old or young, it returned the string young or it returned the string old, right? So here, this OOY is a string. The string is one of these two values. So here I can say if it's young, then the cost of a ticket is $5. If it's old, then the cost of a ticket is $3. And then we want to print out the cost. Let's save it and let's run it. If I say I was born, oops, what did I do else? Oh, LF. There we go. LF. So 1980. Then my ticket is $5 because I'm young. If I was born in 1970, my ticket is $3 because I'm old. So, why do I return here? Oh, this is a better example. So why do I return there instead? What if I just print the function age? And if I don't return, what happens if I don't have a return, if I just do a print? This is a valid function. It's not going to crash here. But if we look here, we said the age is equal to this compute age, right? But my compute age, it doesn't return anything. So what's going to happen is this age is actually what they call none, meaning it has no value. For example, if we just print, let's see, age here, let's watch what happens. For one, it crashes, but why does it crash? So we asked the year that you were born. We said the age is equal to that compute age. So now we come up here, it does this work. It prints the age, which is where we get that 41. There is no return statement. So whenever I said this age is equal to whatever it returns, then I'm going to print the age. That's where I get this none right here. In Python, none just means no value. It does not mean zero. Zero and none are completely different things. Okay? None means there is no value. So now later, whenever I try to use that age in one of these other functions, I try to say old or young and give the age. That age is still none. So I'm trying to do this right here when this is none. So it makes no sense, right? So you need to have that return. And not just that, let's say for this old or young, so here we're using it for a movie ticket, right? It's cost. So that's it for the movie ticket, right? So you may say, well, why don't we just say, if you're that, print movie is $5 or print movie is $3, right? And take out all this stuff, right? Could do that. let's show you why it's not a good idea to do that. So it does say the movie is $5. Okay. Well, what if we have some more code in here later? That's, we have a bunch of other code in between. And here again, we do old or young. And let's just say the age is 61. But we're going to do this to see if you're old enough to ride on an airplane, right? So if old or young is equal to young, then we're just going to say print, you are not old enough, right? Else, if old or young is equal to old, print, you are old enough, right? So what's the problem here? Let's say, this was get movie ticket price, and this was old enough to ride on airplane, right? So we have two kind of independent pieces of code. A movie ticket price is completely separate from if somebody's old enough to ride on an airplane, right? But they both want to use this common function. They both want to use this function to determine if someone is old or not, old or young, right? So is this going to work? Save it. Let's run it. You're born 1980, and it says right here when we did this old or young, the movie is $5, and here when we're doing this old or young, it's still telling me the movie is $3. But this doesn't have anything to do with a movie, right? I just want to know if somebody's old or young based on what their age is. And that's why for reusability, so that you can use the same function from multiple locations, you generally don't want to have these print statements, because these print statements are usually very specific to what you're trying to compute. Like here, I'm trying to compute the cost of a movie ticket. Here, I'm trying to compute if you can ride on the airplane. Both completely separate things, but they both need to know if you're old or young. So that's why you generally do not want to do print statements in your functions. Generally, there are some exceptions. There's always exceptions, but especially when you're doing some kind of computation, you want to return the value instead of printing out what the value is. In the main part of your program, that's where your prints should be. Okay, let's talk about your assignment, and then we will take some questions. Let me find it. Try to read it right. Okay, so for your assignment, you have to make your own function. You have to compute the cost of carpeting a room. It says your program should prompt the user for the width and length of the room and the quality, and then a choice between 3 grades, yada yada yada. So let me do an example of something that's somewhat related to your assignment, and then you'll have to transform it from there. So let me do an example. Let's say we want to compute the tax on a car. All right. So let's make a method that computes the tax on a car. So let's make our function define. Let's give the function a name, compute car tax. What parameters do we need to compute the tax on a car? I don't know. Let's just make something up. Let's say the tax is based on the year, and if it's gas or electric. Oops. Simple. Actually, let's say the year. Yeah. The tax rate. Yeah. Those are the 3 things that we need to compute the tax on a car. I don't know if that's really how they do it. Kind of doubt it, but for our little example here, to compute the car tax, you need these 3 parameters. You need the year the car was made, the tax rate, and if it's gas or electric. Okay. So I'm just going to make up a formula. Let's say the tax is equal to, oh goodness, let me just make up something. 2021 minus the year of the car times 0.5 times the tax rate. Okay. And if it's a gas car, we are going to add a surcharge onto it. Okay. So let's say if electric or gas equals a lowercase e, actually, no, sorry. If it's a gas, then we're going to add $5 onto it. And then we can return the tax. Let's just say that's our function to compute the tax on the car. So we're going to define function name, 3 parameters, the year the car was made, the tax rate, and if it's gas or electric. And then we're just going to use this little formula here to compute it. We'll say the current year minus the year it was made times the tax rate. And then if it's gas, then we're going to add $5 onto it and return it. Okay. So let's call this function. First, let's ask the user, year of car is the input, enter the year car made. We need to get the tax rate. Input tax rate. That can be a float. Float input enter tax rate. And then if it's gas or electric, G or E is equal to the input gas or electric, G or E. So we're getting the 3 inputs from the user. So let's compute the tax. The computed tax is equal to, we're going to call our function, compute car tax. The parameters we need to give it the year it was made, the tax rate, and the gas or electric. So let's give it the year of the car, the input tax rate, and the gas or electric. So now we will print out what the computed tax is. All right, let's save it and run it. Let's say it's a 2020, tax rate is 0.5. It's gas. Oh, what did I do wrong? What line? Line 12. Input tax rate. Float object has no attribute GOE. Oh, I put a period there instead of a comma. There we go. Now let's run it. So 2020, 0.5 tax rate. It's gas. And it tells me my tax is $5.50. Does that make sense? Let's check. So I said the year of the car is 2020. So this will be 1. 2021 minus 2020 is 1 times the tax rate. I said the tax rate is 0.5. So this is 1 times 0.5, which is 0.5. I said it is gas. So add $5. So that's where I get the 5.5. Let's do the same thing with an electric car. 0.5 E. And you can see the tax rate is only this. And of course, you can really use any numbers you want. So 1982, tax rate is 0.25, and it's gas, and that's the tax on it, right? And kind of going back to what your question was a minute ago, why do we return the tax instead of printing the tax here? Well, maybe because later, after I've computed the tax, the customer has $10. The customer gave me $10, and now I need to compute the change. Is the customer money minus the tax. Print change, right? That's why we return it, because maybe we need to do more than just print. we actually do something with that computed value. This CT is the computed tax value. We're going to print it out, but then we're also going to calculate how much change to give the customer. So we save this, and if we run it, we have a 2018 model, tax rate of 0.65. It's a gas. So the tax rate is this. That's the amount of taxes, and that's the change we got to give them. So that's why you return the value instead of just printing it inside of your method, because you're probably going to do something with that value. For us, we did print it, but then we also computed, how much change to give the customer. So this is very similar to your assignment. Your assignment, instead of computing the car tax, you need to compute the cost of some carpet. You give it the length, the width, and the type of carpet. And then you have to do some kind of mathematical computation to compute the cost. Then you're going to return the cost. And then you have to do some inputs and some outputs and things like that based on what the assignment is telling you to do. Okay. One more thing I want to talk about before we open up for questions is, let me put my spreadsheet again. I'm going to hit on one more time the test cases, because last assignment, I would say half the people didn't even bother to do test cases, and half of those that did submit them didn't submit them correctly. So one more time for test cases. This is what is required of test cases. You have test case number, you have inputs, you have expected output, you have actual output, and then you have pass fail. Expand those out. So for example, let me do a test case on this little tax thing we did here. So for the first test case, let's say we did 2020. Excuse me, test case 1. I'm just going to do 2 test cases. So let's say I put as the input the year 2020, a tax rate of 0.5, and gas. What do I expect the tax rate? Excuse me. Yeah, what do I expect the tax rate to be? How much taxes do I owe? The thing is, you need to compute this by hand. So if we look at our formula here, let's compute it by hand. So for expected output for 2020, this would be 1. So not 0.05, let's change it to 0.5. So this would be 1 times 0.5, which is 0.5. It's gas, so I expect $5 more. So I expect this to be 5.5. Likewise, if I put the year 2020, tax rate 0.5, and electric, I expect it to be 0.5 as the tax rate, right? Let's take this change stuff out here. We don't need it. So those are my 2 test cases. In reality, you need at least 5, but I'm not going to waste everybody's time and go through 5 of them right now. So let's run this program, and we will execute the program, and we will record what the actual output is. So let's run it. Let's give it this input, which is 2020, 0.5 gas. It tells me the answer is 5.5. Do those 2 things match? They do match, so it passes that test case. Let's run it again with this test case, 2020, 0.5 electric, tells me the answer is 0.5. That also passes. That tells me my program is working correctly, right? Let's imagine I had an error in my program. Okay, I kind of established this is what my tax rate is. Let's say I accidentally messed up and added this on there. I have a bug in my code somewhere, right? So I would still have this expected output because, ignore this for a second. This is really what the computation should be, but I made an error in my program and accidentally added 1. It's a bug in my program. So I still have the same expected output, but let's see what my actual output is now. So when I run this, the same parameters, it tells me the answer is 6.5. And that fails. Let's run again for my other test case. It tells me that's 1.5. That also fails. Whenever you have a fail here, it means there's a bug in your code and you need to go fix it. So I go back and review my code. And I'm like, oh, here's where I made my error. I'm not supposed to add 1 onto it. I have fixed my code. So now I need to go back in here, delete these out, and run my test cases again. Run that, it's 5.5. It passes. Run it with the other input. And it's 0.5. And that also passes. This is what your test cases should look like. It's covered now in this video. It's covered in the last video. It's also covered in the week 3 class materials. So if you aren't doing these for your test cases, then you don't get, you miss out on the points for test cases. All right. I'll go ahead and open it up for questions. You're welcome, Cameron. I'll hang on for a couple more minutes. This does get recorded, and I will get it posted up and a link put out to the class whenever it's available. So wait about 1 more minute if there's any last second questions. All right, we'll go ahead and wrap it up and look for the link that I send out in a little while. All right, have a good rest of your day.